Hello everyone. So today we have a very interesting topic to talk about. It's called cloning, or in other words, copying objects. Some people might think that copying objects is as simple as copying primitive data types, primitive variables. So today I'll be showing you that this is not really the case, and in order to have a real copy of an object, we need to do some coding. I will be showing you two different ways of copying object. One is the traditional way, which we call cloning, and for that we'll talk about two different types of cloning. One is called shallow and the other one is called deep cloning. And finally, I will show you a more advanced way of how copying is done in industry with real life examples. So let's start by giving you a brief on what is the problem when we try to copy objects. For that, let's start with a new project. For today, we will, let's say we have a cloud manager, okay, application app. And for simplicity now in the main class, I will just show you a quick example of what do you mean with or what is actually our problem. Let's say we have int x equal 4, int y equals 9. And now when I say int z equal y, initially we all know that z will have the value of 9. So to prove it, we can print and if I later on decide to change the value of z, so z equals 3, for example, and then again I will print and I will validate against the value of y, which we started with. So what do you think the output will be here? I started with a value of 9 for y. Actually, x is not needed. I don't know why I created it. Anyway, and then we copied y to z. I will print the value for z. Obviously, it will be the same as y in this case. But now the question is, after changing the value of z, what will be the value of z and what will be the value of y? Will they have the same value again or things will change? Let's see. If we run now, I believe if you guessed that z will change, z will 3 and y will remain 9, then you're right. This is what we understand when we say we want to copy. So we copied y to z, but then afterwards, both are disjoint. They are not related to each other. Sadly, this is not the case when we talk. These are primitive types, but when we talk about objects, things are a little bit different. Let's say instead of having an integer, I will have an array list of, oops, I will have an array list of string, and this would be name list equal new array list. Okay, obviously we need import java.util.star, and let's say name list dot add. I will add my name as a starting value. All right, and then I will copy this to name list, copy name list, and then instead of this equal name list. So basically I'm copying the original to the copy one. So let's remove this. We don't need it anymore. This is also no longer needed. So now what I want to do is the following. I want to add to copy name list. Okay, dot add. I will add another name. Let's say now I will add John Doe. So what do you think will happen now? How many elements do I have in name list? How many names do I have in the original one? And how many names do I have in the second one? Well, I would say in the name list we have Imad, and in the copy name list we have now Imad because we started with a copy of the name list and then we added John Doe. So we have two. Let's check this out. So S out, let me simply just print the size for name list is plus name list dot size. And then let me copy, oops, let me copy this and paste it again, but now for the copy name list, now for copy name list. So let's see. What do you think we'll get now? So let's run. And as you can see, name list is 2, copy name list is 2. Although I only added one name to name list, and then later on I added another name to copy name list, but eventually they both ended up with two values, two elements. Why is that? This is the problem we're talking about. This is what happens when you try to copy objects. If you believe that copying an object is as simple as saying object A equal object B, then you're wrong. This will basically create for you only another reference for that object. So it's like two people sitting in front of a TV, each one has a remote control for the same TV. If you switch the channel, then you and your friend will be seeing the same channel. If your friend will switch the channel, again, both of you will be seeing the same new channel. So two references for the same object. So let's fix this. Let's see how can we really have one copy of the object. So in order to do that, let me start by creating a class, and the first class for today, I will call it hardware config. So let's say we have hardware configuration and we have a server. So we would like uh, to copy, for example, configuration from one server to the other. I want to copy one server to a new server, etc. So let's say here in hardware configuration, we have RAM GB for the RAMs, and we have a string for the, let's say, storage type, whatever type of storage we have. We can quickly refactor, refactor, and then we encapsulate, select all, refactor, and we can insert code for a constructor, select all, and then generate. So I will have a parameterized constructor. So this is the first class. Then that's a simple class. I will have another class called server, whereby we have a relationship, simply an association relationship between server and the hardware. So the server, ideally, it will have a name, so a string server name, and in addition to that, it will have hardware. Am I typing right? Yeah, hardware config instance, and this will be my hardware. All right, again, we will do exactly the same. We will refactor, encapsulate, select all, refactor, and I will insert a parameterized constructor. So basically, we have something similar to the array list example, where in the server we have an instance of hardware. If it's only primitive variables like this, primitive data types, then we have no problem. But the problem is when we have objects referenced in other objects. Here we end up with the same problem as the array list. So basically, what do we need to do now? We need to first, I will show you what we call shallow cloning. Shallow cloning is basically what we just did with the array list when we end up with simply another reference for the same object. How do we do that? In the old days, there was an interface called Clonable, and we were told anytime you want to activate cloning, all you need to do is ask your object to implement the clonable interface. And here with the clonable interface, we have where is it? Override. We have the clone method, and this is what we need to implement. So this here is the clone method, and this method throws, remember we talked about declaring exceptions, throws a clone not supported exception, and this would return a copy of the cloned object. So basically what we need to do here is simply change this from object to whatever object type we are cloning. So here we are in the server class, and here we need to parse to server. So we end up with simply copying super.clone. This will give me exactly the same result as before, like the one we did here. So we can quickly check. Server A equal new. Sorry, before that we need to create hardware. So hardware config config A for server A equal new hardware config, where we need the gigabytes. Let's say we have, I don't know, 256. That's too much. 32. And then what else do we have? I forgot. We have the storage type. So in the storage type, oops, we're here. Let's say we have SSD. So this is my hardware configuration. And now when I say server A equal new server, for that we need a server name, server A, and we need the hardware configuration. This would be config A. So that's my configuration. Now I will copy this. I will create another configuration. I will call it config B, and this will be, for example, 16, and we'll keep it as SSD. Okay, now let me go back to these two classes. Let's add, just for simplicity, we'll add a toString method, generate. So, and here also in the server, we'll add the toString method, generate. Do I have any error? Yes. What's the error here? Expected. Did I sorry, implements. My bad. All right, good. So let's go back here. Let's say now I want to display this out. Okay, server A. Sorry, we named it A dot toString. Okay, and then here I will create server B equal A equal, yeah, sorry, A. So I will copy um, the exactly same configuration for both. And now I will display for B, and then here we'll have B. Okay, so now without doing anything, it's clear that A and B, they are exactly the same at this moment because we did not do any changes. Let's confirm. So if we run, you'll see server A is server A, hardware config 32, and then 32, and the name of the server is still the same. All right, so as we saw, we have an identical copy, and actually what we can do here is we can use .clone to use the function we added. And as you know, clone method, when implemented, it was declared to throw this exception. So obviously we will need here to catch it. Yeah, so try, and then we will catch here. Let me copy it quickly. We will catch clone not supported exception. And we'll display the message as usual, e.get message. Okay, so this will give me the same. Until now, we haven't done anything to confirm whether this is shallow or deep cloning. So to check if this is really shallow cloning, let me try to do the following. Let me take the copy, so B, and then I will try to get the hardware, all right, and I will try to maybe set, let's say I will change the RAM. So set the RAM, initially we have in B, we have 16, um, or sorry, in B, which is a copy of A, the RAMs are 32. So let me change that to 64 for B, yeah? So B here. And let's display the server configuration after the change. Let's see if this will make any difference. So I'll adjust the statement S out after change. So let's see how this will affect our server configuration. Just 1 second. I like my code to, oops, to be aligned. Okay, and there you go. So let's run again. No, not here. It's here. Run. Okay. Yes. So let's see what we have now. Before we have server A and with the configuration as config A, 32 and SSD. We copied B, we copied A to B, um, originally same configuration, but then later on, when we changed B only. However, this was also reflected on AY because as we said, both are two references to the same object in memory. So what we will be doing next is we are done now with shallow cloning. I will proceed with deep cloning. I will remain in the same with the same classes, but we will work on implementing deep cloning. So with deep cloning, we will try to do the following. If we change B, yeah, it will only affect the server B because both are independent disjoint objects in the memory. So how are we going to do that? Usually with deep cloning, we start from the lower level of the hierarchy of objects. So basically here with hardware config, we will implement clonable. We already did actually, so we have it here. Nothing special needs to be done in the hardware config. Now we go to the server. initially what we had exactly the same code as in the hardware config, and as we saw, this was or this resulted in having a shallow copy or another reference for the same object in the memory. So what do we need to do now? In order to implement the deep cloning, first of all, we will start with creating a server, and I will take away this. And this will be my server. I will call it cloned server equal. Simply, I will clone the existing server. That's the first step. Then, what I need to do now is I need to clone the hardware configuration for that server. So I will end up with a completely disjoint object. So I will take this cloned server and I'm interested in changing its hardware equal. I will take the current hardware, this dot hardware, and I will call the clone method on it. And this will return for me a cloned hardware. And finally, I will return the cloned, cloned server. Okay, so this will get me, will first clone the server. It will then clone the hardware, and it will change the hardware for the cloned server. Okay, and finally I will return the cloned server. Everything else will remain the same. So let me go back to my driver and we'll run it again. Let's see what will happen now. And there you go. As we see, before change, nothing happens, still the same. But what we have now is something interesting after change. So now we do not have identical configuration. No, A remains intact, no changes in A, because obviously I only changed using B, changed the configuration for server B. However, B here was really affected, and we have now 64 GB RAM. You can change, for example, A, and you run again. And as you can see, B is still the same, 32, as it was a copy of original A, and A now is 64 GB. And this is how you implement deep cloning. All right, so this actually is using the clonable interface. However, recently in industry, they have let's say an easy way, if you would like to say so, easy way to implement cloning to achieve deep cloning as we did now. So two independent copies of the object, however, without implementing the clonable interface. How do they do that? They create what we call a copy constructor. So we are familiar with the term default constructor, parameterized constructor, and this copy constructor, maybe it's new to some of you, but it's nothing special. It is a parameterized constructor. However, the attribute, or sorry, the parameter is object of the same type of the class. So let's start with, regardless, we will start with the hardware config. I will create a constructor, so I cannot insert that, public hardware config. So instead of giving RAM, GB, and storage type as parameters for this, I will give a parameter of the same type. So I will call it HC. All right. So now what I will do, did I copy it right? Oh, sorry, my bad. So it's hardware and hardware. All right. So now what we will do is the following. Simply, we will take this dot ramgb equal exactly like we did before equal um, instead of directly assigning, we will take it from the object itself and from the parameter, sorry, and this dot storage type equals hc dot storage type. Okay, so more or less it's the same, but the parameter itself is an object of type hardware config. We move to the server class and we will do exactly the same. So we will provide another constructor for the server class. So public server, oopsie, server. And as we did with hardware, we will give a parameter of type of type server. I will name it S for simplicity. And then we will do exactly the same. This dot, we have server name equal S dot name, S dot server name, sorry. And this dot hardware, and now that's the key point here. I cannot say S dot hardware here. No, I will have to create a new hardware config, and basically I will call the constructor we just created, this copy constructor, and this will take care of those two. So that's the only thing we need to pay attention to. And here, what do I pass? I pass the hardware configuration. And where do I get it from? From my server S. So S dot hardware. And this is enough for creating the deep or implementing the deep clone, or simply speaking, creating a separate copy, independent copy in the memory. The only thing is here in the server, we had to write in clone, we had to first clone the server and then clone the hardware. So instead of calling the clone method, we simply create a copy constructor. Let me write that for you. So copy constructor, whereby here the server name is a primitive data type, so it will be assigned directly. But what we need to do for the hardware, we need to call the copy constructor for the hardware class, which we just created. And with that, now we can go ahead and test the implementation um, of um, of deep cloning using the parameterized the copy constructor, sorry, that we just created. So how do we do that? This is what I will be showing you next. So now let's go to the main class again. What we did before, we just created or we called the clone method for both, and then we tested that with either the shallow cloning or deep cloning. But then later on, um, with deep cloning, we ended up with a separate copy. All right, so now I will keep this, but I will show you the same, um, implement the same using the copy constructor. So what do we do? I want to create a copy of server A, but I don't want to use the clone method. So I will start with creating an instance. So the key point here, I need to use this constructor, the copy constructor, and that's it. I don't need to use any other method. So server, I will call it modern server. So this will be a new, and then I will call server, the new constructor we have, modern server. So the question is, what do we pass here? We pass the object that we would like to copy, and in our case, this is A. So now this is my copy server. To directly test, let me try to change something for, obviously here, no need to tell you if we print, again, if we print here, server A, and then I will call this modern server, this will be, let me copy this quickly, modern server. So if we run now, oops, if we run this, then again, no surprise, server A and modern server A are both 64. Remember here we changed. So that's not a surprise. Now the question is, what will happen if I try to change something in modern server? So what will happen now? What do you think? So let's, for example, try to change as we did before. Let's try to change RAM, for example. So modern server dot get hardware dot set okay, set RAM GB, and then we'll give 128, for example. What did I do wrong? Modern dot get set RAM. Oh, my bad. GB. Let me increase a little bit. Oopsie. Come on. Okay. So set RAM GB. Okay, and again, we will copy, we will display for both after change, and let's see what will happen. So if our work is working fine, if our code is working fine, then we should have 64 GB for A and 122 for modern server. And drums. All right, and there you go. So server A, we have 64, and modern server is 128. So basically we achieved exactly the same using the copy constructor. All right, and as you can see, it's as simple as calling this constructor. I'm not saying this is complicated, but you know, it's matter of preference. Now you have both, and you can use freely whichever method you prefer, as long as you understand what each method is doing and what are the important points to implement each of the ways. That's it for now, and I'll be seeing you soon in another video. Have a good one.